Okay, in 12.2, we're going to talk about total surface area of pyramids. In 12.1, we talked about prisms. Definition of a pyramid. We've actually gone through pyramids. I think you remember in section 9.8. So a lot of what I'm going to talk about is going to seem a little repetitious, but you know, you can refer to your 9.8 notes for all the parts of the pyramid as well. Okay, a pyramid has only one base. Its lateral edges meet at a single point, the vertex. Its lateral faces are always triangles, always triangles. Okay, so again, they meet at a single point known as the vertex. Okay. Again, how to draw a rectangular pyramid, you draw a parallelogram, or if it's a triangular pyramid, you can draw a triangle, or if it's a hexagonal, you can draw a hexagon. And then just draw a vertical line up from the center, and then just connect all of the vertices to the tip of the vertical line. Just like that. And we went over that again in 9.8. Again, there's different kinds of pyramids. You can just make note of these. You don't have to have these on your note sheet, but a triangular pyramid, a rectangular pyramid, a pentagonal pyramid, and so on. There are several. A regular pyramid. I know we talked about a regular prism, but think about the fact that it's not possible for the lateral edges to meet at a right angle with the base. It wouldn't be a pyramid if so. Okay, so a regular pyramid, all that means is it's not a right, but it's a pyramid with a regular polygon as its base. Also, what you need to know about a regular pyramid, okay, is that it has congruent lateral edges. So its lateral faces are always congruent isosceles triangles. Okay. So again, a pyramid with a regular polygon as its base, it has congruent lateral edges, and its lateral faces are congruent isosceles triangles. Okay. This is going to be a recap, so this is actually not on your note sheet, but you can make note of it if you want. We've talked about the important parts of a pyramid, so I'm going to kind of go through these pretty quickly. You have your base, okay, you have your vertex, and remember, PR, the height of the pyramid, is known as the altitude of the pyramid, and it's perpendicular to the base. Remember that PS is known as the slant height, and that is notated with your italicized L. Okay. And then you have your lateral edges. Okay. Hidden right triangles, we're going to go over this once more. You can have a triangle made up of the altitude, half of the side, or the what we would call, I guess, an apothem if it was regular, and then the slant height. Another one is dealing with the slant height, half of the side, and then the lateral edge is the hypotenuse. And then a third one is dealing with the altitude and half of the diagonal. In this case, half of the diagonal and the lateral edge. Okay. All right. This next part is optional. Now that you have it filled in, we're going to do just a simple application with pyramids. So we're going to go to our applications. Oh, I'm sorry. We need to go back. We're going to go to slide. Okay. So we're going to record the formula for lateral area of a pyramid. Okay. The lateral area of a pyramid is a little bit different than the prism. Remember, the prism lateral area was the perimeter of the base times the height of the prism. Well, specifically with a pyramid, you're taking the perimeter of the base, so that's very similar. Okay. But what's different is you're multiplying it by the slant height of the pyramid. So it's not the regular height. It's not the altitude. It's the slant height of the pyramid. Okay? And then you're multiplying it by half. We'll talk about why that is tomorrow, why you multiply by half. Okay, but again, the perimeter of the base times the slant height of the pyramid times half would be the lateral. And then surface area is, again, just lateral area plus the area of one base, because obviously a pyramid has exactly one base. Okay. So now is the time that we're going to try an application using this formula. Let's take a look. So we have a square base, okay, and we're going to find the pyramid's lateral area and total area, okay. Notice how we have a lateral edge of 5, and that is not the slant height, so we're going to need to find the slant height, okay. So again, lateral area of a pyramid is half the perimeter of the base times the slant height, okay. So we're going to have to find the slant height. So let's go ahead and draw in a slant height. And we know that the slant height is perpendicular, and it also bisects the base side in half. So we know that's a 3. So we have a triple going on here. So we have a 3, 4, 5. So the slant height is 4. Okay. So we can go ahead and find our lateral area. So we're taking half. The perimeter of the base is 6 times 4. 4 sides, and then the slant height is 4. Okay, so we have half 24 times 4. So our lateral area is 48. And we don't have units here, so we'll just say unit squared. And then the surface area, we're going to take the lateral area and we're going to add it to the area of the base. Well, since the area of the base, or since the base is a square, we can just do 48 plus 6 squared. So that gives us 48 plus 36, which gives us a total of 84 units squared. So here's our lateral area, and here's our surface area. And that is how you find the lateral area and the surface area of a pyramid. We'll do more applications tomorrow. I'll see you then.